This video explains how to create a component for process modeling. Select the Home tab, click Geometry in the Import group, and import a machine body. Select the Modeling tab, click Move in the Manipulation group, move the machine body, and split the geometry as follows. Select a door and extract the link. Select link_1 and select Translational from the pull-down selection of joint type. Set +X to axis and change the joint name to door. Select New Servo Controller to create a new servo controller. To set the movable range of the door, set minimum limit to 0 and maximum limit to 550. Select link_2 and select Translational Follower from the pull-down selection of joint type. Set -X to axis and door to driver. Click Interact in the Manipulation group and check the movable range in operation by dragging the door. To change the component color, click Tools in the Geometry group and select Assign of Material. Change the color of some parts of the machine body to light_orange. Select the work table where a workpiece is placed and move it to the center of the machine body. Next, add 3 frames to the position where a process is executed, the position before the process is executed, and the position where a resource stops. Select the Modeling tab and create the first frame. Place the frame in front of the machine body, which is the position where resources such as a human and AGV input the workpiece. Change the name to Resource Location. Select Object for coordinates. A human or AGV turns in the direction of the machine body. Create the second frame and change the name to Process Location. Move the frame to the position where the process in the machine is executed, and rotate the frame 90° counterclockwise. Create the third frame and move it to the position where the robot approaches process location. The robot moves to the third frame position before placing the workpiece in the position where the process is executed. Change the name to Process Location Approach. Since 3 frames have been added, add a container to store the workpiece. Click Behaviors and select Component Container. Change the name to Component Container __height___. Statistics can also be added from behaviors. It is used to measure statistical information, such as capacity utilization. Add an operation for process modeling by the following steps. Add transport node. To define the machining position in the machine body, set the container that you created to component container and the process location frame to visual position frame. Set the process location frame to default product position frame and the resource location frame to default resource position frame. Configure the frame setting to place a node in the machine body. Add process executor and set transport node. With this setting, the workpiece can be transported inside or outside the component. Select the component container and set the statistics. Select the Process tab and click Processes in the Editor group. You can check that processes labels are assigned to other components. However, the machine body does not have any process, so that its process label is not displayed. Click the blue circle on the machine body and click the plus button. Process 1 is created. Change the name to My Milling. Add a statement to the process as follows. First, add set state of statistics statements so that the statistics set in the machine body can be changed. Add transport in for the robot to wait until the workpiece arrives and then transport the workpiece. Add delay and set a 1-second delay. Add move joint to close the doors. To move the selected joint, set servo controller to controller, door to joint, 550 to target value, and 1 to motion time in the statement properties window. The doors can be moved 550 mm in 1 second. Add set state. Use delay to set processing time. Select the Modeling tab, click Properties in the Properties group, and select Distribution. Change the name to Process Time, set time to Quantity, S to Magnitude, and a constant value of 5 seconds to Value. A random value such as Normal Distribution can be set from the Value Distribution selections. Return to the Process tab and select Delay. Set Expression to Time Source and set the distribution that you created to Expression. The process execution time can also be set. For the door open operation, add move joint. Set servo controller to controller and door to joint in the statement properties window. Set 0 to target value and 1 to motion time. Add set state. For the robot to wait until the resource arrives and pick up the workpiece, set blocked to state. Add transport out to transport the workpiece from the process. Place the machine body next to the robot. Secure enough space for the robot to move, and place the components. Configure the flow settings so that the workpiece is transported from the first machine to the machine that you customized and then to the conveyor. Click Flow in the Editor group. Delete to Conveyor of the flow group number 1, and delete the arrow that connects the first machine and the conveyor in the 3D world. Select the process label in the order of the first machine, customized machine, and conveyor, and click the robot controller and the icons on the arrow line. Right-click on the icon and select Change Transport Controller to configure the setting for transportation with the robot. Perform the simulation and check the operation. A cube flows on one conveyor and a box is created on another conveyor. The robot transports the cube to 2 machines and puts the cube into the box. This is the end of the explanation of how to create a component for process modeling. Thank you for watching.